Welcome back, everyone, and we're going to continue building our ECS framework into Fungi, actually, integrating it. So where we left off is before we had our transform and our rendering systems and components all set up, and so this way we can actually start rendering a single frame of 3D information. Now we're going to deal with input and then start building our render loop, so this way we can do continuous updating of the data and then continuous rendering of the data. So here's our main HTML page, and if you remember correctly, in the previous file I had something called new draw. I threw that function in a new class called API, simply because I have no place to put it. I really have absolutely no place to put it. I don't know a good place to put some of these functions that makes things a little easier, these abstractions. So I just created, so API seems like a pretty decent small name to use, and all my functions in there are static. So this way I can just dump whatever, abstracted functions that help me use ECS, improve it. So this way, instead of me doing all of this, I can just call API new draw and we're done. Now I have this commented out because grid floor is no longer being generated here. It's now available in the app with a new function called load scene. So when I'm done, and I'm passing in finally the unrender function, a reference. So this way, the render loop will then just constantly call the ECS update systems function to actually update our systems and do our rendering. And just like in our previous Fungi system before ECS, we just start up our loop when we're done initiating everything. So yeah. So let's look at some quick changes that we did to app API and app.js. And like I said, we have a new load scene, and that gives me the ability to kind of control what I want in the scene. So if I want to draw like a default scene, this is where I can probably put all my code. So in here I have like dynamically loading in grid floor, and setting all the variables, and I'm setting everything manually. No big deal. I can use the API function if I really want to as well, but I'm just doing it manually here. But yeah, load scene will basically be here. Maybe I'll have another function called load dark scene, and that will have all the settings set up to load the dark scene instead, things like that. So yeah, and it's all asynchronous. So first it loads everything else, and when that is all done, and then calls load scene, which is another asynchronous. So when that is done, it calls that. So it's asynchronous, but at the same time, it's sequential by using this kind of then promise framework that exists in JavaScript. So that's load scene. So that makes things a lot easier. And now in here, we're starting to load in. We have we're loading in our camera component, which I think I already was doing before. This is the new things we're actually loading in. We're loading in our input tracker and a render loop, and we're also loading in our camera system. Even though I call it a camera system, it really takes the input from uses the data from input tracker and then applies it to the camera. So this we can have control over our viewport. So we can use the mouse and keyboard to walk around our 3D space. So camera system I added manually, and it has a priority of 10 for now, and I think I changed the priority numbers. I want to spread things out a little bit, so it's easier to kind of just throw something in the middle. So I want the camera to process first. Then I want to update all the transforms, because again, camera systems are going to change the transform for my camera. So that has to happen before the transform, and then when I'm done rendering all my transforms, then I actually do rendering. And then here, input tracker gets saved into a global function called input, so this way I can access it if I need to globally. And my render loop, if I pass in my callback, I then create the render loop and then pass it in. So this way I have access to my render loop, and the render loop exists on a global scale. So I can turn on and off basically the game, or just stop rendering altogether. All right, so those are the changes we did to app.js. So now we have a little bit more functionality to start up our system. Like I said, API is something I just kind of threw in there, and to control, in true sense of functional programming, I need to know where left, right, and up is. And in a previous, like a year ago, I showed you that the model matrix has that data in there. But originally, to get the left, right, and up, that was built into our transform object. And since transform object now really is just a struct of data, functionality's got to go somewhere. And instead of dumping it into the transform, I decided just to dump it into the API, just to make it a little easier, because it's, just to make that file a little bit smaller, and I can have more access globally this way. So this is like a private function matrix direction. This is exactly what was inside the transform previously, and I just create these global these static objects that automatically you pass in the entity, hopefully that has a transform, and then it uses that transform data to pull out the left, right, up. And I call it local because actually, you know what? It's called local for now, but the model matrix can be the world matrix. But that's like I said, I built this before I actually did hierarchy. So this can be world left and world up and world forward, not local. So this might actually have to change in the future. So it's not really actual local. It could be world. It depending if you're using the transform or transform hierarchy. But that's like the last video in the series. So that's what API is. Just a place where I can just throw in my functions to use to update and modify my ECS components. Now, input tracker. I've in a previous video I've done a character control where you can control a character by moving it around our scene, and I showed you how to take the keyboard input events and kind of turn it into state information. So all that is here. I probably just added a few things here and there. So the key events, every time you do a key down event, it saves it to a key state and sets it to true. And then the only difference, I'm actually keeping count of how many keys are currently being held down. So when the system, when I'm running through the system, I can see, is the count 0? I don't need to process anything. That means I don't need to process keyboard info. So this way I can not have to go check everything. Because if the key count is 0, that means nothing's being held down. So that's a new addition I've added to this component. And then key up, it sets that state to false, and it de-increments the keyboard, the key count. So this way we keep track of how many keys are being held down at the exact same time. And this is the key function, so we can actually grab state. We say, give us the code, and if it's true, it returns true. That means that button is currently set as true. It's currently being held down. So our input tracker can only tell if the key is currently being held down or not. It's a binary choice. It's either on or off. That's all it does. So that's what we did in the character controller, and I also have a couple like extra functions. Is shift, is control. It just checks the states, some Linux functionality. Now, the next thing is now keeping track of the mouse data, because that's also event driven, but we need everything to exist as state information. So to keep track of wheel data, I need every time the wheel data changes, I have to change something, because wheel data is either -1 or 1, and I can't. It's hard to check. So the easiest solution I found was have a state where, based on the fungi render loop, I just take that current time in the render loop, because that time is linear. So this way I keep track. So if I keep track of the update on date in my system, I'll know exactly when this was changed. So this way, if I see that this value is different from what I stored it, that means whatever value this currently is, just use it now. You'll see how it works in the system. This is our regular keyboard stuff, and this is the rest of our mouse. And this is a lot of what it was in my keyboard key VM object. So it's a lot of the same data. The only difference is I'm keeping state now. Before I just stored this information, but now I'm storing state. So left mouse if the mouse is currently down, or the middle mouse or the right mouse is currently down. And is mouse active is if any one of these is true, then this is true. So So instead of me checking to see if any mouse down, I can just say, is mouse active? If the mouse is not active, I can just automatically ignore and don't bother checking any of the other states. So we're going to keep track of its current position, the initial position when you push your mouse down, the previous position it was, the delta since initialized. So when you press down, it saves the initialized data, and then I do like a subtraction or something from the current state, and that's the delta. So we know the difference since the beginning. The IDX is more useful in this system, where previously I used the PDK, which is delta since previous, but because of the system, this actually makes more sense and it's easier to use than this one. But I keep all the data regardless, just in case I need it for any specific reason. And the rest is just regular stuff to kind of start. Just to get the left and right bounding box of the scene, so I can do offsets based on where the mouse is. All the bindings are done here too. So that's the constructor. Update coordinates. It just sets just all the math. Again, this is all the same thing that we did for our previous mouse controller, so we control the viewport. So there's nothing much has changed, except everything is kind of more state-based instead of everything being driven based on events. I disabled right click. Right click doesn't function anymore, but I can use right click because I can track the state. I just prevent the browser for itself from using it. So this way the context menu doesn't open. So now, previously, where I only had access to the right click and maybe the right click, I only had access to the left click only. Now in this new input tracker, I have access to left, middle, and right. So I have more flexibility to do things with input in this version. ECS doesn't necessarily make it this. It's just I just went back to the drawing board and recreated my input tracker and added mouse to the state functionality, so it makes it a lot easier. And this is how I keep track of the state for wheel. I just prevent it from running, I save the value, and I save the date, and that's it. Very simple. That's every time the event runs, it just triggers that. Mouse down. It's a lot of the same code. Like all this is this is the same thing for mouse down from before. Now I just add all the extra state information in there. And if any of these state options are turned on, mouse event is added. A mouse move event is added. I did that previously. And then I check to see which mouse button are you using. Is it 1, 2, or 3? And I denote which one is currently which one is currently active by doing the mouse down button. And again, if any one of these are true, that means the mouse is currently being used. That means I can't do mouse over if there's no mouse down. So mouse down activates basically all the state data information. Mouse move, all it does is just runs the update coordinate system, and mouse up is the same thing as mouse down but kind of in reverse. It checks to see which mouse is up, so this way I can change the state. I double check the mouse state in general, and if the mouse is completely inactive, I remove the mouse move event handling. So this way I'm not doing things every time the mouse is moving, because I only want to track when the mouse is down. And that's the input tracker. And the last piece of the thing is the actual camera system. So this is the system. It has a lot of the same stuff that our KVM has. It's almost the same thing. The only thing is, I can't remember why is active. Because I do have an active. Okay. I forget what this one is for. I was going to write a comment, but I didn't write it. Mode. Remember in the previous video when we built our camera system, we had orbit mode, and we kind of have like a free mode, so we can kind of just walk around, and we have panning mode. So we have like three modes of mouse interactions. I save the initial rotation and position on mouse down of the camera, so this way we can use IDX and IDY. So the change since init can then be added to the initial position and rotation, so it actually makes things a lot more smoother than in previous iterations of our camera controller. This is the main update for the functionality for our camera system. And like I said, if no keys are currently active, if there's a key that's currently active, then handle the keyboard. This one is for the mouse wheel. If the mouse wheel changed, I'd save that value back into our system, so this way I can keep the system tracks if it's changed or not itself as well. Transform CC. So I just get some attributes. Then I use the API to know where forward is, and basically it's the same stuff from our mouse camera controller, which just moves the camera forward and back based on where you're looking. If the mouse is active, I say is active equals false. I guess I'm keeping track of mouse activity this way. So like I said, I didn't write a comment for it. So if the mouse is active, basically the first time the system detects that you did a mouse down. So that's what this really means. So I'm using that as a state to tell if the mouse is down for the first time, because I'm no longer I'm not reading events, I'm reading states. So that's the big changes. So I need to I have to track this current state of the last time I looked. It's kind of like our gamepad video where I showed you that we have to pull the information and we have to keep track of what it is, because it can change from the last time we checked. So this is basically pooling essentially. And if this frame is the first time I detected there's a mouse down, I then do this bit of information. So that's what is active is. It's active for the first time. And then I just check to see if the IDX changed since the last time I did anything. If it did, I handle mouse. If it did not, I don't bother. So again, there's a lot of checks to see not to waste time processing data if I don't need to. So I try to minimize as much as possible. And handle mouse is pretty much the exact same code from before, just a little bit small changes. Like I even left the comments of different ways of doing it. This is the look mode, this is the orbit mode, and this is the panning mode. So it's all the same code, it's just slight variation changes. I don't want to go into too much detail because we've done this before, it's all the same. Like I said, there's probably just small changes, like I'm using the local API for get left and passing in the camera entity. And handle input from keyboard is the same. It's different. This is more if statements instead of switch statements. So this way I can hold down the forward button and the left button at the same time so I can walk diagonally. So everything's if statements. So I can actually handle multiple key states at the exact same time. And everything kind of just builds up. So if I'm holding down W and S, I can add to position. And here I'm also adding to position if I'm going left and right. If I'm rotating, so this way I can move left and right and forward and back at the exact same time. So that's kind of why I have it built this way. So we have more. So this is more like our character controller type of functionality. And that's it. That's our system. And if I were just to go here, our camera works. It works the same way that it always did. I have panning if I hold down the shift button. If I don't hold the shift, I do a look. So I'm just looking around like a first person camera. Yeah, and panning and holding down control does my orbit, and shift, yeah, it does panning. And that's it. That's input, and that's how we handle input into our new ECS framework. Yeah, so just more data. Like so, even though I built input as more of a class object, like I said, this is a hybrid system. So I'm not going to build this as a component, then have a system run on it. I rather build this as a global object, essentially because I'm using event handling, because I have to access the events from the system and then save that data. I don't want to have you can't really have a system that handles events like that. So that's kind of why this has to work the way it is. Like it has to be class, or it has to be it makes more sense to make this as a class object. I'm not using an inheritance or anything. So, like I said, this is kind of a hybrid system. It's not completely pure. It just makes no sense. And I think if you're going to even do C++ and you have events coming in, you're probably going to build it this way anyway. So, I can't see a simple way for events that happens randomly during time being handled by ECS. This is not very possible, because ECS is based on data and logic, and event handling is not data and logic in the way how it works in JavaScript. It's because we have no control over events, basically. I have no control of when the user is going to access. So that's why I need to build it this way. Okay. Hopefully that makes sense. Because it's random. I have no control over it. So this function just makes it so it's easy for ECS systems to know what the mouse and the keyboard is doing. And yeah, I guess I'll end that at that. So now we have input, and we can now we're back. We can render, we can move around. Now we can start doing some more fun things with Fungi and build a lot more complicated components and more systems. And then eventually we're going to reach hierarchy. Okay, so please like and subscribe, and see you guys in the next video.